Hi, and welcome back to day 2 of the Canadian Underground Forum. This morning we've already heard about technology involved for underground asset management, and now we're going to go into the standards side of things. Now you're probably familiar with the Open Geospatial Consortium, and they have a standards working group that's working on MUDDI, which is kind of appropriately, I'm getting used to the acronym, kind of an appropriate and fun acronym for this, but Model for Underground Data Definition and Integration. This morning we have Neil Brammall, who's the CEO of Utility Survey Exchange in the UK, and Carsten Roensdorf with the Ordnance Survey of the UK. So gentlemen, please take it away.
Well, Carsten, there's that. My name's Neil Brammall. So I represent. I'm representing today the Geospatial Commission in the UK, who is working on the National Underground Asset Register project, which is as part of that project we are implementing a harmonized data model, which is based on the MUDDI standard. So after Carsten has given us a bit of background, a bit of an introduction to the model, I'll hopefully share a few insights and reflections on actually implementing that. Sure, yeah. So this might be slightly out of context and a bit muddled. So, but hopefully there's that shouldn't matter too much. So I was going to talk about the first of all the excavations subgroup, which is a subgroup of the broader MUDDI standards working group. And the MUDDI data model is on the development of the model is framed through the lens of various use cases, and the first one being addressed is that of excavation, which is all about is a support to the safe and efficient planning and execution of excavations. So this subgroup, as I say, focuses. Focuses on the requirements of this use case and provides recommendations for consideration of the wider standards working group. I just wanted to go through some of the topics that are currently under discussion by that subgroup, and then I'll move on to some reflections on actually implementing the MUDDI model in the National Underground Asset Register project, which is underway in the UK. So there are various topics, as I say, under discussion by the group, and some are quite well advanced and close to resolution, if you like, and some are a little bit of an earlier stage, possibly a bit more contentious and requiring further discussion. Some of those that are quite well advanced include discussions on elements of asset age, and this is really all about representing characteristics of assets such as date of installation, date of digitization, date of last update, last survey, etc., and all these different waypoints, if you like, in the physical and the digital asset life cycle of an asset, and in the context of planning and executing excavations, these can give really useful context to planners and excavators, and we want to ensure that the data model supports those nuances. We're also are very conscious that district heating or more generally thermal networks is a big growth area, is certainly in the UK, but across the world really. and we're very conscious that the MUDDI model needs to reflect the assets involved in that sector. There's been a lot of discussion about representation of asset capacity. So making sure the model provides sufficient flexibility in the representation of things like voltage level, pressure, which may of course support broader considerations of risk and hazard in the excavation use case. And also we've worked on recommendations about the ability to provide annotations, measurements, and associated documentation to be linked to particular assets or particular locations. And as I say, for all of these, we're very close to providing clear recommendations for adoption by the group, and then it's over to the data modeling experts in the group really to implement those. There are a few areas where, as I said, there's more discussion to be had, and that's about representation of information around risk assessment and hazard, representation of depth, and particularly discussion of relative depth, if you like, depth of cover, and as opposed to height above datum, and a lot of discussions about guidance around alignment, relative alignment of assets to a base map. And I think with all these, there's perhaps a general theme which might emerge, which is the debate around explicit versus implicit representation of this information. For instance, do we provide an explicit means of representing a concept like hazard, or do we rather provide the ammunition, if you like, for an implementer of the model to draw out a representation of hazard based on local standards and norms and the requirements of their use case? So we provide the metadata for that representation of hazard to be drawn out further downstream, if you like. And this isn't a binary argument. As a group, I think we're looking to find an optimal point on the spectrum, if you like. And we're also not just restricted to the blunt instrument of updating the data model. That there are also options to provide examples and guidance and best practice. So yeah, this brings me on to the work that has been done on the NUAR project in the UK, as I say, which includes development of a harmonized data model based on the MUDDI model, and gives a useful outlet and feedback loop for these debates and discussions.
So thanks for bearing with us, and I hope Neil will be coming back in a little while. So we're jumping back into the earlier part where I said that I wanted to give a high-level introduction into the underground work at the Open Geospatial Consortium, introduced the MUDDI SWIG, which I guess Neil has now done to a certain degree, with a bit of a focus on what we call the excavation use case. He will talk later about the data model, and then if we have time, about the UK implementation. So I think I skip that and move right to back into 2017, when we had really the starting point of the most recent story where OGC got involved into underground. And this is an interesting picture and an interesting article that was published in Bloomberg Business Week at the time. Nobody knows what lies beneath New York City, which really tells the story about underground information and really knowledge about underground infrastructure, or the lack of that understanding. And what we did in 2017, we organized the workshop, and we got sponsors together from 3 different cities, from London, which was represented by Ordnance Survey, New York, which was the fund for the city of New York at that time, and the Singapore land authority who all had a particular interest in the underground. And we published a call for information to basically say, well, tell us what your view on underground data is. Tell us what you think the problems are, whether you have any solutions, whether you made headway on any kind of implementation, and how do you think standards would relate to underground and underground data. And that resulted in a report that was published under this title, Underground Infrastructure Mapping Modeling Study, or Concept Development Study. That's what CDS stands for. And yeah, we looked really at a variety of different technologies and approaches about things like semantic modeling of utility networks and other underground structures, transport infrastructure we perhaps didn't go that deeply into, but something we called underground environment, which is a term that really describes the shallow geology, soils, and groundwater, and then the interaction with the man-made networks and civil infrastructures. And one of the key outcomes of this work was a recommendation that we had at the end of this workshop to say what we really need, particularly from a standards perspective, is the need for an integrated data model that allows us to bring together and integrate or make data interoperable from all these different domains. To dive a little bit into, or give you an insight into the type of information that we got back, this is an interesting overview that was put in by Accenture at the time, which talks about the return on investment on accurately mapping underground infrastructure in a number of pilot projects that were done mainly in North America. And you can see the spread here of a return on investment between around 3.5 and 21 times the amount of investment that you put in. And I think that gave us some comfort that there was really something in this, not only from a technical perspective, but also from a business perspective, and that it was a worthwhile topic going into, because we saw really a user need, and we also saw, as illustrated on this slide, really the potential to make something happen, because it looked like the business case would stack up. This is probably the most important slide in terms of the outcome of this workshop, and you see a URL there to the report that we published, which is still openly available on the OGC's website, where we looked at the different use cases in the underground, because one of the things that we identified quite early on is that it's not one single use case in terms of knowing what's underground. There are several ones, and we grouped them into these 6 different categories, where the first 3 really have to do with the operations and utilities, from routine street excavations, perhaps laying new networks, fiber networks, doing replacement projects. The one excavation in front of my house you saw earlier, maintenance problem, and emergency response, which is obviously to repair network plant when things go wrong. And we really distinguished this from things like large-scale construction projects, where obviously, or in many cases, not knowing what's underground adds a significant project risk to your construction project. The use case that was coming, I think, most strongly out of New York City was really disaster planning and response, and to be ready and resilient to see what's going on in terms of natural disasters such as Katrina, a hurricane, or a storm surge that would potentially then take substations out of the grid, or in New York City that actually happened, as well as smart cities programs, so the number 6, which is the rather big bucket, which also includes urban planning, which was the case that our friends in Singapore were most interested in. So if you look at how utility data is currently being mapped and represented, this is a slide from 4 depictions of utility network in the UK and the northeast of England, where we've done a lot of work with the preeminent utilities in this area around Northumbrian Water, Northern Power Grid, and Northern Gas Networks, as well as British Telecom from a telco perspective. And what we see here is obviously quite traditional paper maps. Quite often they are available as PDFs. But what's important about this is that they are really separate map representations for each network. And when we spoke to the utilities, I think everybody said that we really want to have this integrated on one single map. Now, there's one other approach, and I think Josh Lieberman from OGC put this slide together with a reference to Lewis Carroll, that quite often a map at the scale of a mile to a mile or 1-to-1 is basically being done, when, as we see here, the utilities come out with spray paint and mark what they believe to be underground, in a variety of different colors. So since I think in 2020, I think we kind of came together throughout lockdown. A group of let us call them or us enthusiasts on underground data has really found together. We're working on we have an input, which is what the OGC calls a draft engineering report, which is essentially an early version of a candidate data model for this integration. So that came out of the second workshop that was done in New York City a few years ago. And we're currently looking at that, but the group is constituted of really data experts and enthusiasts in underground data from around the world. So we actually do have quite heavy participation from Canada with 4 or 5 people, from the United States, from a variety of countries in Europe, and I would include the UK in that definition, as well as out of Asia and New Zealand. And we have 3 objectives, 3 high-level objectives. One is to create a standards roadmap to see what do we actually need to do in terms of publicizing standards and perhaps additional guidance and best practice documentation on making interoperability in the underground a reality. We have worked on what we call a generic conceptual model, where we have this candidate model that Josh Lieberman put together for underground data, in which a variety of different utility types as well as soil and geological data comes together, and then also publish an encoding standard, which would be something that can really be implemented in technology. So the reason to do the conceptual model is that we have the case that we have pretty much, or a very similar problem in, I guess, pretty much every country around the world, but obviously different environment, different legislative approaches, different situations in terms of the ownerships and the regulations of utilities in particular. And what we want to distill is to basically the common elements that would go into that could be used in every country. So the idea is that the conceptual model would basically be a Lego box that you can then tap into and put an implementable model, which would be the encoding standard or the interpretation of the encoding standard in a particular jurisdiction together and implement this in your country. So I think that's basically my part. I think I saw, if I saw this correctly, you're back online, and I guess you did the first part of your talk about the excavation subgroup already.
Yeah, if Neil, if you have a couple of minutes, if you have some wrap up, because your audio went offline all of a sudden in midstream, so you have a couple of minutes.
I do apologize. I had a complete meltdown of my laptop at this end, and I hadn't realized I was speaking to myself. But yeah, really, this I just wanted to, if I've got a couple of minutes, I just wanted to reflect on the implementation of the MUDDI model as part of the new R project in the UK. And this often starts, the first question we need to answer sometimes is well, why bother with with a harmonized data model in that project, and you know, possibly preaching to the converted on this in this forum, but it's often useful to come back to these fundamentals. And obviously, I mean, you know, I won't dwell on some of these, but you know, the benefits of having a standardized representation across geographies, across sectors, you know, the benefits of that speak for themselves in terms of removing ambiguity in the field, etc. in that excavation use case. And of course, having a target, a standard target, really helps to refine the ask really of asset owners in terms of onboarding data and making the update of that data repeatable and sustainable. But one element which I'd really like to I really like to focus on just in the minute remaining is perhaps sometimes overlooked, and the opportunity for data quality improvement, and by measuring and reporting to asset owners the level of conformance of their data with a standard target data model. That's a real opportunity to provide objective feedback about data quality, and you know, that's you know, isn't the magic bullet. It isn't the answer to all data quality improvement problems, but we see that as a real opportunity to provide objective feedback, which will at least allow asset owners to focus in their data improvement efforts on particular areas, and just gives a starting point to that process for asset owners. So yeah, I realize we're probably out of time, but I just really wanted to focus in on that particular aspect. But I'll be happy to answer any questions on our implementation efforts, I guess.
Thank you again, Neil, and thank you, Carsten. And I wish we had time. You know, I've seen some comments already, like Joshua, but would love to go into like code lists and semantic interoperabilities. And I wanted to go into the implementation arm. I mean, where we would see this, like in the, you know, the IFC and UNADE and, you know, things to do with GeoJSON, et cetera, because that's where the rubber will hit the road. So we have to move on to the next presentation, but Neil and Carsten, I want to entertain the idea of perhaps a recorded webinar where we could go into some details in the near future. I think that would be really, really good. So thank you again, Neil and Carsten. And if folks have questions, they can put it up in the Q&A box, and maybe you can answer some offline or stuff like that. We got to move.
To do that.